All right, so welcome back, everybody. Zen introduced me earlier, but my name is Mike Hallock. I'm going to be talking to you over the next, well, I won't quite need an hour. It's going to be a little bit more of just some background knowledge on the cloud. We'll talk about what is cloud computing, how we're going to leverage it, and then we will get into the applied portion of trying to make sure that you guys can all actually get onto an instance that I've set up for you. And so we'll be able to go around the room and have time to correct any issues or have comments that we'll see if we can take care of. So yeah, so as I said, we are, the title says Easy Simulation Execution Using Amazon Web Services.
Yeah.
I don't know where this title came from, but easy for you, hopefully, in the sense that things should be ready to go. And then, what is AWS? Well, AWS is a cloud computing platform. Oh dear, what does that mean? This is sort of a buzzword, cloud computing, but what I mean by it is that, it's using infrastructure that you are physically interacting with, that exists somewhere out there. It's all computational power infrastructure, so it simulates networks, do all sorts of crazy stuff with it, and you're renting every little bit of it, by the second. So get out your credit card, open an account, and then start clicking away, and you can build all sorts of interesting applications. We're looking at it more of just as a platform to provide compute cycles to you guys, specifically ones that have NVIDIA GPUs attached to them. But the concept around AWS and other cloud computing platforms is really being able to dynamically respond to needs. I need 10 more servers now, so click go. Scale out horizontally, which is what I was doing at lunch. Instead of being social and talking to any of you, I was sitting over in the corner, quickly firing up 20 instances here for you guys to use. And it doesn't take that long. But yeah, so as I said, this isn't anything that we're physically interacting with. AWS is a global network of infrastructure. We'll be running today out of Virginia. But there are regions that are all over the world. If you think about if you were building like an e-commerce website, might help that you can spread all over the place, get lower latency by being closer to your customers. And certainly, if you were to go home and use this, yes.
I have a question. So, for somebody opening a lab, should they buy a cluster or not? So
Should you buy a cluster or not? Okay, so comes down to how often, or what percentage of time do you expect that you're going to have your equipment idle, and being able to appropriately assess that is your factor. The instances we'll be running today, they cost 65 cents an hour. So you do the math. If you're going to spend a couple $1,000s on a computer, and it turns out it's gonna, you're gonna use it 3 days a month or something. If you're an experimental lab and you needed to crunch a data set, that you get off a microscope once a month or something, is it worth buying hardware to do that? Maybe not. Maybe this is the appropriate venue. Do you want to do the cloud instead of like traditional HPC, where you expect that you're gonna have a lot of load, hopefully most of the time? No, probably not. Because as I said, you're renting every bit of it, so you're paying for amount of disk space you're using, you're paying for the CPU time, you're paying for bandwidth transit in and out. So in terms of it being a dedicated thing for education, I don't think so.
But Mike, don't you have to have the instances up there, to make it worthwhile? if he wants to use software that they don't have up on the cloud somewhere, then, either he makes the instances and puts them up there. And the 65 cents per hour we get, that's sort of, is that the lower end? Because I thought we were requesting that it's available to us for a certain time period, like for this afternoon.
Sure, well,
Multiple
I can
questions.
talk about the pricing here in a second, in a little more detail. So I think one of the benefits of AWS is that it is ready when you want it. If you want it right now, you can have it. If you want to run on like the newest GPUs, there's instances where they have the B100s. It'll cost you $24 an hour, but that's cheaper than buying the $11,000 GPU. So, but if you want to use it around the clock, yeah. So, do you feel that answered your question well enough? Or?
It's about $100 a year.
What was that?
Like $100 a year for a cheap computer. It's actually really good.
Sure. It frees you from having to maintain it. If it breaks, you need to deal with repairing it. So there's a lot of attractive options for it. Whether or not it's a cost-effective option for you, though, really it depends on how much you're using. So as I said, we're mostly using it for compute cycles here during this workshop, but they offer a ridiculous amount of services. And this slide, I think I took this screenshot, a year or so ago. I think there's, probably twice as many icons now. They're always adding new features and functionality. So we are using what is called as EC2, their Elastic Compute Service. There is all sorts of other interesting things you can do in here. There's one called Lambda. Essentially, you can set up automation pipelines where, upon an event, say a file gets saved into a place, it can dynamically spin up some compute resources to execute some sort of function against it and shut back down immediately. S3 is their storage bucket service. There's things that sort of mimic NFS, if you're familiar with that. There's all sorts of scalable database services. It really is quite a complicating thing to maneuver when you're getting started. I still have no idea what 90% of this stuff does. So if you have the opportunity to ever, I know at least on this campus, we offer AWS training like every month or so. We have one of the, we have a tech that works for Amazon, comes and helps guide tutorials. So I've played with like their all-size flight service, which is the build a cluster in one button tool. It's kind of neat. It takes a little bit of getting used to. There's a lot of moving pieces. So yeah, it's not something that's for the faint of heart either.
Can I ask a question? Your previous slide, you had numbers on there, and I noticed we're using Virginia, you said number 5. Why is San Polo 3, so is Oregon 3? Does that just indicate higher the number, the more options you have, the more different types of nodes?
Sure, I skipped over that. The number in the circle is the number of availability zones that are in that region. So each region that is shown here, and this is again old, so there's probably more. Each region is really a completely independent copy of AWS. There is nothing shared between them. They may offer certain services, certain node types in some regions that they don't in others. So these things are really distinct at that level. The number inside there is the availability zone. you can think of that as the number of data centers that make up that region. So, if there is some sort of serious event on the East Coast, like Zan had mentioned earlier, you'd hope that maybe not all 5 availability zones in there get affected at the same time, so that the entire region isn't down. The thing that Zan talked about earlier, that actually was the case. It was a complete disaster and a nightmare, and just our luck. So yeah, so when you're building out these things, you are building out your infrastructure in specific regions, but then the availability zones, you need a little bit more play to migrate between. So what can we do with this? So we're going to be using LLM in the cloud, and how is that really any different from using it on your desktop? And the answer is it's not that much different. You can bring in data. You're going to be able to run these notebooks. You're going to be able to do analysis. The only difference is you're paying as you go rather than running it.
Can I ask you a religious question?
Yes, you
Can you
may.
in principle use Mathematica as easily as Jupyter?
Can you use Mathematica as easily as Jupyter? If you're talking from just a holistic standpoint of the notebook concept.
With AWS specifically.
Oh, good question. As long as your licensing works out, there's no reason you couldn't. We'll get to talking about the marketplace here in a minute. I don't know if Mathematica has any ready to go. Click and run. But I'll
What
talk
about
about
just
that in a
comparing
second.
MATLAB and the Jupyter notebooks? Because I see that, in this campus, we're not supporting like MATLAB for everybody anymore.
Sure. MATLAB and Mathematica are commercial software. You pay for them pay for the right to use them. Yes, our campus pays, to do site licenses, bring that cost down. So yes, it's not free for necessarily everybody, but $25 for a license is far less than if you were trying to do it as an individual license.
But what about what you can do?
What about you can do? I probably can't answer that concretely. MATLAB, if you're familiar with MATLAB, if you have a lot of experience with MATLAB, if you're comfortable working in that environment, that's great. If you're comfortable with Python, you will find yourself very much at home with Jupyter. The additional things that Jupyter provides you in terms of that notebook modality gives you a little bit more of a richness that MATLAB doesn't. But it's really of personal preference, I'd say, at the end of the day. I'm a C programmer. I'm not much of a Python guy, but I will pretend to be one tomorrow. Back to the cost thing we had talked about, what it costs. So if you are willing to tolerate some volatility, you can, essentially there's a market of pricing that's going on at all times based on the current load. So you can get things 60, 70, 80% off the list price by doing what's called spot reservations. So this 65-cent instance, at this particular time, you could have gotten it for between 11 and 14 cents. The trick is you list what the most you're willing to pay, and if the instant price goes above that, you just get shut down. Turns out it's a really bad way to run a workshop, as we learned. When the demand spiked to like $3 an hour, and half of the class, lost their instances all of a sudden. So you have to be able to tolerate that losing your work at any minute. But it's a great way to play around. So if you were to sit down at AWS today, how would you get started? The first thing you need to do is to create an instance. And an instance is the term for what's essentially like a virtual machine out there in the cloud. And you pick sort of what your starting image is. So, we're starting with Red Hat build or Amazon's Linux or SUSE Linux. What we're doing today is we are using the VMD and NAMD image that you can get out of Amazon's marketplace. Amazon's marketplace is essentially the store that companies can go and build images that have their software in it and then make them available to you. This one's obviously, there's free software, we make the image available for free, but perhaps if Mathematica, if Wolfram does have an image, and I'd have to go check, they may have a price attached to it to use it by the hour as well that covers the cost of the software. So you'd be able to go in there, you can see information about, what you're getting here, tells you the pricing information and usage instructions, gives you some links, back to us. So what we've actually done for you today is we've started with this image and then we've added Lattice Microbes on top of it, which is not currently in the marketplace. We'll talk about the next time we refresh this for VMD and NAMD that we'll add ourselves in there. We're not there today. So what are you going to be able to do? There's two major modes of access for how you'll access these today. You'll run Jupyter either right out of your web browser, or you can actually use remote desktop, or VNC actually. We use a client called DCV a lot. In the future, we will use DCV as the server, which does accelerated graphics through VNC. It's super slick. It's really impressive to see, on a little tiny wimpy laptop, doing this giant visualization, of a 200 million atom simulation, and it's just smooth as butter. It's really quite impressive. So you will be able to use the DCV client or real VNC to connect to these instances as well and use the desktop. We're all going over wireless here, so it may not always be the best experience. But do give it a try, and I think on Friday you will get to play with the Lattice Microbes plugin to VMD, which is how you will do it. So as I said, the Jupyter Notebook is the first way here. You will just go to a URL that I will give you here in a few minutes, pull it up. How many of you actually have Jupyter on your own machines ready to go? A few of you, great. So you've already had a chance to play with Jupyter a little bit in that case, but if you haven't, Marcelo will be walking through that with you guys next. In terms of the remote desktop, I said that DCV client, you'll put in the IP address and the password for your instance, and you get the desktop, and you can launch graphical applications and whatnot. Last thing I want to mention that is more of a commercial than anything, and nothing we'll be leveraging today. NVIDIA started this thing called their NVIDIA GPU Cloud. Despite the name, there is no cloud that they are creating, but rather it is a registry of CUDA-enabled software that's sort of ready to deploy. They're using Docker. It's sort of like a very lightweight version of a virtual machine where you can essentially tarball up a whole machine and have some tools to be able to run that. So they have built this repository for applications that all use their hardware, and they have like their deep learning instance on Amazon is all set up to use their registry, or if you configure your own computers to use the NVIDIA Docker extensions. So for example, Lattice Microbes is part of this registry, so if you were in an environment that could use NGC, that command is all you need to run to install and be able to use Lattice Microbes. So, with all of that out of the way, what I will do is I have for each of you a piece of paper here that includes the information for your instance. What we're going to do is we'll be leaving these running during the workshop times and take them down in the evenings just so they're not paying normal nights. So on the middle of the page here, when you get it, you will see an IP address. You'll be able to go to that in your browser. The DCP information is below. The magic of this thing is, even though I've tried to set up exact copies of everything, like biology, this is sometimes stochastic. So if you find that something does not work for you, just let us know and we'll see what happened. Try and get you rebooted. So if everybody wants to, attempt to go and open up Jupyter in their web browser, we can at least quickly make sure that everybody's set to go there. If you have any issues, speak up now. Get it taken care of.
And this will work tomorrow too, so they should keep these.
Yeah, hold on to this piece of paper. This will be good for Thursday and Friday.
Wrong password.
Yeah.
No.
Yeah. Well. So the VMD and NAMD image, that password is actually the instance identifier that you get out of AWS. So when you're sitting in front of an AWS console, that is what you're actually seeing, and it's nice and easy to copy and paste. I can actually go ahead and show you here. What the AWS side of things looks like. So I'm over here at the list of instances, and we've got a whole bunch of workshop images that are running. And these are all these instance IDs and your public IPs. So,
Wow. So you're watching people get on?
These are just everything that's already running. So, if you were wanting to launch an instance, you go here. Since we were asked earlier, let's see if Mathematica is an option here. Do not see a Mathematica. So nothing out of the box there.
I don't think AMI needs to be fixed.
No, I was just
Linux kernel
curious. Yes.
versions.
Oh, of course. So.
Let's go.
So yeah.
Everybody in?
Yeah, I'm downloading the PDFs and, fixing things. Good. Am I signed up server?
Were you able to get it?
So that's
Yeah, I have this.
Great. Yep. Yeah, we'll be going over the tutorial next. This is just really make sure.
It's the part of the job.
It said
You've been using this for a while.
We have Jupyter. Running on our own machines, like
So Jupyter, they
Just
you
that
can
you
have
can
all
use
the
it.
stuff that.
We would set up our level, we had started installing our we would spend the whole.
All the.
So it is have peace of mind, try and read that you haven't had, Python 3 installed. And
So,
what are the
I haven't started this
like,
so using this.
Yeah. So DCV, we won't actually use until Friday. It's just if you wanted to give it a shot now.
When you try to download it, put it on your machine.
Give some kicks.
I saw this. So Jupyter, it works in the web.
You open a local Jupyter, basically what it does is it creates a server.
Was everybody at least able to get into the Jupyter notebook? You should get to a screen once you put in that password. There's docs and tutorials are your two links. So under.
We'll just check. Are you there? Oh, he's already on the
Really
tutorial.
interesting because it makes it really easy.
Are you there?
to use
Yes,
this
yeah, very good.
stuff. And then you can do that access as well.
Yeah, we're gonna do there. And then we'll start you going on the various
You know, you
tutorials.
guys use the website, just like if you were
Okay, yeah, he's there. Everybody?
Because you know,
Yeah, you're working ahead.
so it's, we were actually.
Okay, and you got everything? Yeah, you're running. All right, you overachieved. Okay, I think they've all got it, Mike.
Great.
That's all right. That is perfect because the problem is how much it costs to run it. So when we're on Amazon website, we get the question.
Okay,
Same thing.
so do you want them to run one of them? or click on one?
No, it's okay.
All right, does everybody have a window that looks like that?
Yes.
Yeah, that's kind of
When
like.
you actually-
So under the docs,
Marcelo? Hey, guys. So it's got, just want to be sure everybody's seeing that.
yeah, I was just gonna say under docs, if you go to there, when we get to it, under the HTML docs, if you click on this index.html, it's gonna bring up the Lattice Microbes documentation that's currently on there.
Wait a minute, how did you get there? Which one did you click on?
Sure. So under doc, and then there's HTML doc. There's also the PDFs, I think, in that top level directory. Click on HTML doc, then you click on the index.html.
After the HTML. Index.
Yeah, index.
Can you like comment?
Yeah, okay.
Make it a bit larger?
Totally, I can do that.
Or you can move up.
Awesome, thanks.
Yeah, if you click on index, it will take you to
Good eyes.
Right, data, simulation data.
And then under tutorials will be all these tutorial links under the Python one where you'll find Marcelo's tutorial that we'll be going through after the coffee break.
Okay.
Or whatever it is.
So we seem good so far?
Yeah.
All is perfect.
And then yes, sometime between now and Friday, if you haven't downloaded the DCV client, I believe Shashank emailed everybody yesterday the links for downloading that client. Find time to do that install and give it a try. Connect to the desktop, and we can certainly.
Is that much better?
That's just will be for doing VMD on Friday.
Oh, yeah, you gotta do it. No question, got it.
We don't need it today. We don't need it tomorrow. By Friday,
Yeah, okay.
we'll watch that running. So, cool. Any other questions, or we can wrap up early? Let me rephrase that. Is there any questions?
So, then, wait, just so now we got it up, where are you gonna start, Marcelo? Are you gonna start with the Python
Sure.
directory?
Yes.
I have a question.
course.
About the DCV installation.
Yes.
So one thing that I read, I installed the VNC,
Okay.
not the DCV.
Okay.
I don't know if that is enough for Friday.
Yeah,
Okay.
if you're able to connect to it.
I already connected here.
Yeah.
So.
The reason, so DCV, as I clumsily mentioned, but we'll do some more articulately now. DCV is a VNC compatible server that gives the additional capability of doing 3D graphics better. Essentially, instead of trying to transmit all of the 3D graphics information over the wire, it actually compresses it into a movie stream and sends it. You know, it's like watching Netflix for your simulation. So what Amazon has actually bought the company that makes the DCV server. So we expect in the next iteration of the NAMD and VMD images, we will be using the DCV server instead of a traditional VNC server.
What does DCV stand for?
I don't know.
No, Google it.
Yes.